Okay, so we are going to first, this is the homework for the Ka, Kb calculations. Please note that I will be simplifying stuff a lot as we get more and more into it, but I will do the full calculations for at least the first two questions. So vinegar, 0.83 moles per liter acetic acid. What is the percent dissociation of vinegar? And calculate the pH. So it's a double-edged, double question. So we will write our dissociation equation for acetic acid. We will then continue our ice table, 0.83 minus x, 0.83 minus x, 0, 0, plus x, x. And now, okay, we have to calculate the pH. We know that in order to calculate the pH, we need to calculate H3O plus concentration. In order to calculate H3O plus concentration, I have to use some formula from an ice table. I do not have my Ka provided to me, so that means I'm looking at the back of the textbook for my Ka, which I will look and see that it is 1.8 times 10 to the power negative 5. So Ka, back of textbook. So I'm going to put in brackets here, back, equals, well, x squared divided by 0.83, not minus x, because I'm also going to do 0.83 divided by Ka greater than 500, justified. Right, so this is my Ka is 1.875, 1.8 times 10 to the power negative 5 is x squared divided by 0.83. So I'm going to do 1.8 times 10 to the power negative 5 times 0.83. Take the square root of that and get x equals 3.86 times 10 to the power negative 3. Hopefully we saw that calculation. Multiply, take square root of both sides, right? So this again is my H3O plus. So pH is negative log of H3O plus. So negative log of that is 2.41. It's also asked to calculate my percent dissociation. My percent dissociation is H3O plus divided by initial concentration of acid, which H3O plus I have just found to be 3.86 times 10 to the power negative 3. Divided by 0.83 initial concentration of acid. Put that in a calculator, times that by 100%. I get 0.465% dissociation of my acid. So, yeah, pretty small. Barbiturates, barbituric acid. Bayer. I wonder if that's where the company Bayer comes from. Interesting. The formula is blah blah blah, blah blah blah. Okay, pH is 2.5. There we go. That's the key thing here. So I have to find acid dissociation constant, which means I have to find my Ka, and what percentage. I have to also calculate percent thingamajig. That's okay, we could do that. From here, first thing I'm going to do is I'm going to say pH equals, I already forgot it, 2.5. 2.5, which means my H3O plus is 10 to the power of negative pH, which gives me 10 to the gives me 3.16 times 10 to the power of negative 3. Sorry about that, it's on 2 lines. But I have my H3O plus concentration. Because now if I have my chemical equation, I'm just going to write, I don't want to write out that entire formula because that's going to be very annoying. So I'm just going to put HA plus water, H3O plus A minus. I can put my ice table in or whatever, but I know initial concentration is 0.1 of barbiturate, or HA, 0.1, minus X, 0.1 minus X, 0, 0, plus X, X, X. But I know X is H3O plus, and H3O plus is 3.16 times 10 to the power of negative 3. So this is also 3.16 times 10 to the power of negative 3. And this is 0.099, which I'm just going to keep it as 0.01 for the purpose of calculations. But you could write 0.099, whatever that is. It 0.096. There we go. Oh, psi. Perfect. Ka equals 3.16 times 10 to the power of negative 3 squared divided by 0.096. I'm leaving you to calculate that. Percent ionization is H plus, which is 3.16 times 10 to the power of negative 3 divided by 0.01, because it's initial concentration of acid, so 0.1, sorry, times 100%. So there's a slight difference there, and they're always, but when we use our approximation method, that kind of disappears, right? Because we just cancel out this negative x here. But when you're showing the calculations, let's try to be as accurate as possible when we show these things. I might have technically also made a couple mistakes by not showing that in the previous video. I'm not sure, but when it's not going to make too much of a difference, so. Who cares? I don't. So in the test, you'll be probably fine, whichever one you do. I won't deduct marks, maybe. Like half tops, not even. Yeah, it's not really helping you, so I'm gonna keep quiet now. Okay. Solution of hydrofluoric acid, molar concentration 0.01. Let's look up HF on this guy. 6.3 times 10 to the negative 4. Okay, so Ka equals 6.3 times 10 to the power of negative 4. Concentration is 0.01. I already don't like where this is going because, oh, yuck. Psi. Okay, this is one of those weird questions where the approximation method does not work, so I'm sad. I apologize for giving you this annoying question for homework. 0.01 minus x, 0.01 minus x, 0, 0, plus x, x, x. Well, okay. Well, that's okay. We'll power through this. 6.4 times 10 to the power of negative 4. What was it? 6.3. Whoops. Equals x squared divided by 0.01 minus x. So let's cross multiply here, and we get 6.3 times 10 to the power of negative 6 minus 6.3 times 10 to the power of negative 4x equals x squared. I take everything to the one side so that I get a quadratic. X squared equals, or x squared plus 6.3 times 10 to the power negative 4x minus 6.3 times 10 to the power negative 6 equals 0. I'm sorry you can't see because of the... Here, I'll zoom in. Now, unfortunately, we have to do a quadratic formula. So x equals, oh dear, negative b, which is negative 6.3 times 10 to the power negative 4, plus or minus square root of b squared minus 4ac. So I'm going to do that. 6.3 times 10 to the power negative 4 squared minus 4 times 1 times 6.3 times 10 to the power negative 6. And I get a negative answer. That's not good, is it? I did something wrong, probably. Oh yeah, C was negative. Whoops. So how do I fix that on my calculator? I can't. I have to do this again. Sorry about the delay. Negative 4 squared 4 times 1 times 6.3 times 10 to the power negative 6 equals, then I'll take the square root of that just for good measure. 5.06 times 10 to the power negative 3 divided by 2. So this is, so I'm going to reject one answer. Negative 6.03 times 10 to the power negative 4 minus 5.06 times 10 to the power negative 3 divided by 2 rejected, as x cannot be negative. So my only other viable option is to do this, minus 6.03 times 10 to the power negative 4, divide that answer by 2. Oh, I lost it. Divide that answer by 2, and my x turns out to be 2.23 times 10 to the power negative 3. Finally. Now let's do negative log of that answer, and we get our pH is 2.65. I hate quadratic formula. There will never be a question like this as long as I live on a test. Well, at least I won't put a question like this on a test. This is extremely harsh. I don't like doing quadratic formulas, especially in a non-quadratic formula doing calculator. Okay. Hypochlorous acid. Okay, so we're given the percent ionization is 0.027. So we'll do percent ionization is H3O plus divided by 0.4 because that's the initial concentration. So I know my H3O plus is 0.4 times 0.027%. So that is 1.08 times 10 to the power negative 4. And I think we can hopefully skip. Okay, well, this is the last ice table we'll be writing because we don't want to write ice tables. AOCl minus plus H3O plus. I'm going to write the final step. We're going to go down to 0.4 minus X, X, and X. And X we know is the H3O plus is equal to 1.08 times 10 to the power negative 4. This is the same as that, which is pretty much the same as that. Whatever this is, 0.4. Ka equals x squared divided by 0.4 minus x. I'm going to do that on my calculator, which is 1.08 times 10 to the power negative 4 squared divided by 0.3966. This is equal to roughly 2.9 times 10 to the power of negative 8 is my Ka value, equals to Ka. And that's that. what is this? 20? Oh, this was 22. We have to do 23 and 24. Okay, we're gonna hurry this up. So I'm gonna do initial concentration divided by Ka. Okay, that was horrible writing, but hopefully you can see that is initial concentration divided by Ka. I think that's greater than 500. Hallelujah, greater than 500. So justified, and I'm automatically going to go to Ka equals x squared divided by 0.01, which was my initial concentration here, just because if I do the ice table, this is what I'm going to get. So I know my Ka is 1.51 times 10 to the power negative 5, multiplied by 0.01, and taking the square root of that, x equals 3.88 times 10 to the power negative 4. Negative log of that gives me my pH, because this is an acid, so pH equals 3.4. Done. Okay, so this is an interesting question. Caproic acid occurs naturally in coconut and palm oil. It's a weak monoprotic acid. Ka is that. Certain aqueous solution has a pH. How much acid was dissolved to make 100 milliliters of the solution? Fascinating. We have to calculate initial concentration of acid. We're given Ka and pH. So this is, again, quite elementary. We will do our ice table, and in our doing our ice table, we will obtain Ka times 10 to the 1.3 times 10 to the power negative 5 equals x squared, which is H3O plus squared, basically. So if you want to so calculate H3O plus from here, 10 to the power negative 2.94, which is 10 to the power negative 2.94 is 1.14 times 10 to the power of negative 3. And that is our H3O plus. So this is 1.14 times 10 to the power negative 3 squared divided by, initial concentration that I want to find, minus 1.14 times 10 to the power negative 3. Right, so I want to find initial concentration of acid. I can mark that as HA. I'm just assigning it a variable C. And therefore what we shall do is we shall do 1.14 times 10 to the power negative 3 squared. We shall divide that by 1.3 times 10 to the power negative 5. So I'm interchanging these. So this entire thing is going to be what I just did. So this divided by 1.3 times 10 to the power negative 5, which is 0.099, and I will add to that 1.14 times 10 to the power negative 3, which gives me concentration initial equals 0.101 moles per liter. So how much acid was dissolved to make 100 milliliters of the solution? Well, I needed to dissolve, to make 100 milliliters, if it's 0.101 moles in 1 liter, to make 1/10 of that, I needed to dissolve 1/10 the moles, so 0.0101 moles had to be dissolved in 100 milliliters. Am I thinking that right? Yes, I am thinking that right. And therefore, how much acid, to go to grams, we have to multiply by molar mass of acid. So we'll look up the molar mass of what acid is this? Caproic acid. Of caproic acid. What is that? 116.15. So I'm going to divide that by 10 times 116.15. And I have to dissolve, therefore, 116.16 grams. Oh, that doesn't make any sense. Times 116.15. I stand corrected. I have to dissolve 1.174 grams of this acid in 100 milliliters of solution to get that pH. Yep, so that was our Ka stuff. Now we shall do our Kb stuff, which is not this stuff. Over here. So I don't know whether to make that a different video. I think I will make it a different video. This is taking too long. So I will pause this. What page number was that? 400. Okay.